Hi, my name is Josh Herzog. I did my final stats project on the NBA draft. So every year the NBA drafts the best young players into the league, and it's kind of difficult to predict who will be good and who will not be good. So what I wanted to do is I wanted to see if I could use historic data from the drafts in years past to make a model that could accurately predict how players would turn out in this year's draft. So the draft is going to be in June. So this is relatively current. So the data that I took was I took data from the draft classes of 2007 to 2009. I used lottery picks, so that is picks 1 through 14. I did this because I wanted to limit the size of of the data that I was pulling because I was pulling this myself, and it took a while anyway. I also used the 2007 2009 drafts because I was able to get an appropriate length on their season or on their career. So I was able to get an actual good estimate of how good they turned out to be. Any time before that, there was different rules on who you could draft. So I think I got the data that was the most recent and also the most relevant. So the methodology that I used to calculate this is through a statistic called win shares. Win shares is calculated using this massive equation up here, and if you look and see all those statistics, those statistics are all gross statistics that are calculated using other statistics. So in all actuality, there is like 50 different things that go into this that get boiled down into this one number, and this one number is able to basically show how effective a player has been in creating wins over the course of their career. So, a good player, a very good player, like an all-star or Hall of Famer, will be above um, 100, but that is very rare. A very good player will be in the 60s, 70s, 80s, and an average player will be in the 30s, 40s, and a below average player will be below that. And the NBA had data posted these for these statistics online, so I was able to grab that from there. So this is what I did for the regression. Um, so first of all, I did the cross validation. So I separated it into a train and a test set of data. After doing some initial tests on of regression on the data, but I found that the significant variables were the offensive rebound percentage, minutes played, field goals, field goal percentage, steals, points, strength of schedule, and years of experience. So these were the players' college statistics that I found to be that were found to be most significant in predicting the win shares. In the model that I created, the adjusted R squared for the model was 37.88%. I also conducted a hypothesis test on the data, and the F statistic was 4.049, and the p-value was 0.002. The hypotheses that I tested were that the null was that the data or that these variables had no effect on the projected win shares, and the alternative hypothesis was that the variables did have an effect on the projected win shares. And because of the p-value and the statistic, we were able to conclude that the variables do have an effect on the win shares. And then looking at the cross validation, The root mean square error ended up being 40. Um, that wasn't that was the best number that I was able to get. That wasn't quite what I was hoping to get, but it will do. So for the plots, first on the left on the untitled plot is the fitted values against the residuals, just to see if there's a pattern. Um, it looks relatively well spread out. There's like no data in the bottom left corner or the bottom right corner, but it looks well spread out. So I think from that perspective, it's a relatively good fit. The uh, the QQ plot it shows a bunch of numbers and a bunch of values below the normality line at the beginning, and then it transitions to a lot more above the line at the end. So we cannot assume normality, which is a flaw in this data set or in this regression analysis. So here's the outcome that I got from my regression analysis. This is for the players that are projected to be in the lottery for this upcoming draft. It it shows a pretty healthy amount of win shares, pretty reasonable, other than negative 36, but it shows a reasonable projection. Um, Obviously, it's hard to guess how accurate that is now, but it was able to do okay on the previous in the cross validation. So um, this is this is I'd say it is a good projection of it's at least a good tool to use when looking at these players. So the conclusion, again, the projections were very reasonable. The large root mean square error does mean there's a large margin of error in the prediction. I didn't make prediction intervals just because there was I had a lot of predictions, so I didn't there would have been a lot of prediction intervals to make. Um, so then yeah, so the variables that were determined to be significant, I examined 31 different variables. These were all basic basketball statistics like field goals attempted, points, rebounds, assists, blocks, steals, all that. Um, those were all, and then the ones that turned out in the model were the ones that were determined to be significant. There was 9 used in the model versus the 31 that were first pulled. Then, because we did use a relatively small data set, it that does shed a little bit of doubt on the results. And then, but it was generally successful. When people in the industry do analysis like these, they have access to full databases curated already, and I had to pull the data already, so I didn't get quite the amount of accuracy I would have hoped for. But using using what I did, it is a successful process, I think. So using more data with the same process would lead to more accurate results. Some improvements that I would make if I did this again, perhaps with more time, I'd use a larger sample size. I'd also use advanced statistics. All the statistics that I used as predictors were basic statistics. I would use advanced statistics like a lot more percentages and pace adjusted statistics and more complicated statistics that have a lot more inputs and generally show a player's effect on a basketball game better. And then the biggest one I think I would do is I would stratify the the players by position so that a lot of the statistics that are more important to some positions than others are highlighted as of being a better predictor. So those are the improvements that I make. Still, I thought that I had a successful project, but that is the end. So thank you for your time and watching, and have a great summer.